So thank you all for coming along. Have you ever, whilst been using PHP, had the thought, if only PHP had a feature that another language has got? Or have you ever thought, I have got this great idea about how I could make PHP even better? Well, this is a story where I had similar ideas to that, and it tells us how I built a new language feature. And actually, that's something, hopefully, by the end of this talk, you'll have an idea of how to do as well. So this story started from a very specific constraint I was trying to apply to my code base, and then I generalized it into a version that could be used on my other projects and potentially your projects as well. My assumption for this talk is that you probably are using SARM or PHP Stan, or are at least aware of those things. So that's kind of my baseline that you are using these tools, or at least aware of them. Okay, so my one example, and you've probably got things similar to this in your code base. I had some code, and I had some code that sent text messages. And what I didn't want to do, for my general code, I didn't want to directly call the code that sends the text messages, because the code that sends the text messages is relatively slow. And it involves HTTP requests, something could go wrong, it might have to retry. We didn't want that slow process slowing down the rest of our code processing. So a pretty standard way of doing this is we had a text message gateway, it would put something on a queue, we'd have a queue processor, and the queue processor would call the send message on text message sender. So what I wanted to do was enforce that the only code that could call the red text message sender box was the text message queue processor. So this is allowed, this is all good, but trying to call text message sender for my general code, not good. And if we look at the visibility modifiers that PHP provides us, it's public, protected, and private. None of these really suit what we need. We need kind of a different level of control. And the reason I want to automate this check is so that it stops me in the future, or other developers, from accidentally calling the slow text message sender code when they should have actually put the request into the queue. And if we automate these checks, that means we'll never forget. We don't have to forget when we're writing the code, and we don't have to forget when we are reviewing other people's codes. Automation is best. So this story, we've got a number of steps we're going to go along. We're going to briefly look at static analysis versus the RFC process. Then we're going to look at something called the abstract syntax tree, because that will give us enough information to see how we can create PHP Stan rules. I'm going to briefly talk about the PHP extension library, which is something I've built using what I'm talking about, and then we'll wrap up with some thoughts. So the RFC versus static analysis. Normally, if you have a new idea for a language, the way you would get it into something like PHP is through the RFC process. So the RFC is a format of a suggestion, and what happens is you would write your RFC, you would chat about it with other people in PHP internals, they'd have a vote, and if you can convince enough people that your idea is great, it gets implemented, and then finally it's in the language. This is a long and difficult process, and rightly so. We have to make sure that the new features we add to PHP are needed and they are correctly implemented. Obviously we get a new PHP release every year in a few weeks' time, and if you were really lucky and the stars aligned, you might go from your initial idea to implementation in 6 months. But in reality, this process takes years, especially for more complex things, which might take a couple of iterations through. But good news, there is another way we can add new features to the language for some kind of functionality. So let's briefly talk about static analysis. If we look at this code and we ran it, we would have a problem when we called the update method on person. We'd get an uncaught error, a call to a private method, person update. The great thing is, we don't have to run this code to see that there's going to be an error. We can just look at it now and reason about it. And that is static analysis. That is looking at the code without running it to see where the problems are. And right now, tools like PHP Storm, SARM and PHP Stan, if you gave it this code, it would all point out the error we've just seen there. And what we can use static analysis to give us extra features. So some of you might have been at the talk just previous to this, where the speaker was showing you how static analysis can give us the power of generics to PHP now. So again, if we looked at this code, we can see that we are iterating over whatever we get from getPeople, and we can see the getPeople method returns something of type array, but in PHP itself, we cannot specify what the elements in that array are. But that dot block at the top, the @returnPerson, open and close square brackets, that is telling static analysis that getPeople is an array where the values are all of type person, and static analysis will also look at the getPeople method to make sure that the array contains only person objects. So that means when we're calling process on $person, and we go to the process method, well, the process method is expecting something of type car, and car is not a person. So our static analysis tools can again tell us we've made a mistake, and essentially what they've done is they have added the feature generics to the PHP language. So I'd advocate adding static analysis to a development workflow process. So at the very least, between writing your code and deploying it to a live environment, make sure it's been through something like SARM or PHP Stan. And you might say, that is all very well, Dave, but what has this got to do with creating new language features? Well, you can create custom rules for SARM and PHP Stan, and those can emulate new language features. And this process is a lot quicker than your 6 months or several years that it will take to do the RFC process. So how can we do this? Great question. We first of all need to understand something called the abstract syntax tree before we can go on to writing our rules. When we execute PHP code, we have our code and it goes through several steps before it can be executed. The first thing, it goes through a tokenization phase where it takes your PHP code and breaks it into logical chunks. And then this is represented in something called the AST, the Abstract Syntax Tree. And that is a graphical representation of your code base. The next step, that AST is used to create opcodes, and the opcodes are run on the virtual machine. For static analysis, we're interested in the abstract syntax tree. So tools like PHP Stan and SARM and PHP Storm do a lot of their analysis on the abstract syntax tree. So any code, any PHP code, and actually the concept of an abstract syntax tree is not specific to PHP. Many other languages use this. But any code you write can be represented in the abstract syntax tree. So imagine we have some code like this, a person notifier class. In terms of how that would look in the abstract syntax tree, we have a node, the red node there, of type class. It's a class node, and it has some properties. In this case, it's got a property called flags. It also has some child nodes. So it's got a child node name, and this is the blue one here, the identifier type, and that's got a name person identifier. So we can see how our class and our person identifier are represented by these two nodes in the abstract syntax tree. A class also has 0 to any number of statements. In this case, we have a property statement, and we have two class methods, the constructor and notify player. So we've taken our code and we've represented it in this tree-like structure. If we go and look at notify player, again, this is a class method type node. It also has a name, it has some parameters, and it has some statements as well. So the key thing is your code base can be represented in an abstract syntax tree, and an abstract syntax tree has got lots of nodes of different types depending on what they're representing, and each of these different nodes have different kinds of properties and different kind of child nodes. Now, if you go and check out Nikita's PHP parser library, this is a PHP implementation of the abstract syntax tree. And I think like the key takeaway bits I really want to say is PHP code is represented in the abstract syntax tree It's made up of lots of different nodes, and the nodes contain the information. And each node has different sets of information. And we're going to see this in action in the next few bits of this talk. So don't worry if you haven't picked it up this time round, we're going to go through it a few more times. So now let's get to the interesting bit. How do we create our own PHP Stan rule? Well, what happens in PHP is we have, PHP Stan is it takes the abstract syntax tree representation of your code base, and it goes through each node one at a time. PHP Stan has many rules, and you can create your own custom rules. And each rule says, I'm interested in a node of a particular type. So maybe I'm interested in a class node, or a property node, or a method call. And as PHP Stan is going through each node in the abstract syntax tree, it says, I've got a class node. And all of the rules that say, I'm interested in the class node, they go and do some processing, and if they find a mistake or find an issue, they'll return that issue. And eventually, PHP Stan has gone through every single node in the code base, and then it returns all the results for the issues it has found. So to create a PHP Stan rule, we need to provide an implementation to this interface. And there are two methods. The first one is the getNodeType, and this returns the type of node that you are interested in for doing this analysis. And the second method is called processError. It's called processNode. You pass into it the node that you are currently looking at, and this thing called scope, which we'll look at later. But this is where PHP Stan provides some additional information about what is going on at that point in the code base. And then you return an array. So if there are no issues, you return an empty array. And if you've got one or more issues, you return an array of ideally rule errors. And this holds information that is then passed back to whoever's running PHP Stan. So if we remember the problem, we were basically saying that text message sender can only be called from text message queue processor, not from anywhere else. So what we need to do is we need to identify what kind of node in the abstract syntax tree we are interested in. So the kind of code we're interested in probably looks like this. This $sender, send message, and then the message. And this is a node of type method call. So we've got a method call. A method call has three properties. It's got the variable that it's working on, in this case, this sender, the blue stuff. Then it's got the name, in this case, send message. And finally, it's got the arguments that are passed to that method call. And if we looked in Nikita's PHP parser library, we would find a method call node. And the interesting bit is generally at the top of all of these classes, you've got the properties. So for example, we have got public $var, which in this example is going to be $thisSender. We've got public $name. In this example, it is send message. And we've got the args that we're passing to it. So hopefully you've seen all code can be represented in the abstract syntax tree. And if we need, when we're doing analysis, each different node type has got an entry in PHP and the PHP parser library, and from that we can get information. So going back to the rule we want to create, I'm going to call it the text message sender caller rule. Bit of a mouthful. There are probably better names for that. And the first method we're going to implement is the getNodeType. We are interested in method calls. So I'm saying I'm returning classes of the method call class. That's the easy bit. The next bit is we need to provide an implementation for processNode. So the first thing we're going to do is we're going to say, what class are we in at the point we are calling this method call? And this is what this line of code does. So $scope provides us additional information for the context of the node as to where it is in the code base at that point in time that we're analyzing. Because obviously, different method calls will have different contexts depending on where in the code they're called. So let's, how do we work out what the calling class is? Well, imagine we had some code like this, person notifier, and we've got $this sender send message. The method call is called from person notifier. So the class we're in, for the code I've put the black square around, we're in person notifier. So if we call this $calling class, get class reflection, get name, it would say my name is person notifier in the class behind. So the next thing we're going to say is if our calling class is text message queue processor, we're going to return an empty array. We're going to say there are no issues here. So if our calling class is text message queue processor, this rule exits and said, I'm okay with this. And remember, what's really going on here is it must mean that wherever the method call is somewhere in that yellow box. So this is all okay. The next thing we're going to do is we're going to get the type of $node var. So as a reminder, for method calls, the var bit is the name of the variable that we are calling, in this case, notify player on. So if we look at this code here, $this sender is a type of text message sender. So $var will be text message sender in this context. So $type will get us information about this, and then we're going to ask, are there any classes? So get reference classes will return the fully qualified name of all the classes that $type could be. And you might be asking, well, how can it possibly be more than one class? Now, in the example we had, and I showed you on the previous slide, it did represent only one class. But in PHP, we can have unions of classes. So in this case, this $this sender is of type text message sender or WhatsApp sender. Now, I'm just using this as an example. In reality, I probably have a base class that both of these things extended. But there are times in our code where we have a variable that represents either one class or another class, which is why when we call get reference classes, it will give us potentially 0 to any number of classes. And then what we're going to do is we're going to iterate through all of the classes that $var could be, and we're going to say, if this class is text message sender, we're going to return a rule error saying, you cannot call text message sender from here. Because if we think about what we're trying to do, we must be somewhere in that blue blob of code. If this is true. So if in the blue blob of code we're calling text message sender, we want to raise an issue. And the yellow bit higher up in this, that says if I'm in text message queue processor, I've already exited. So that means by the time we get to the red box, we must be doing a call which this rule is trying to prevent. And then finally, when we get to the bottom, if all of the possible target classes for $var, if none of them are text message sender, then we fall through the loop, and at the end, we just return an empty array. For this rule, there are no issues. So I'm just going to pop this code here. If you just want to take a moment to digest that, and if you have any questions about this, then do shout them out. I'll just give you a couple of moments to digest that, and then we'll move on. Cool. Okay, so just a few administrative tasks. We've written this PHP stand rule. Where do we put it? I normally create a build folder which is at the same level as my source and test, and then within that I'll have a PHP stand folder for all my PHP stand related code. The other thing we need to do is we need to tell Composer that there is some code, and this is going to be just in the autoloader dev section of it. And finally, we need to tell PHP Stan about this new rule we've created. So in the PHP Stan Neon file, we just need to add to the services a reference to the rule that we have just created. Now, I think this is pretty amazing. We haven't written much code, and we have written a rule that enforces something that from now on, will always catch a possible mistake in the code, okay? And it wasn't a huge amount of code, so I think this is pretty good. But we can do better. The problem with the code at the moment is it is very specific to just something that's specific to one bit of code that I'm working on. It cannot be reused anywhere else. So let's think about how we can change that. Can we have a more generic rule? Can we only call methods in target class from a specified allowed calling class? Then we're generalizing this rule, so this is something that potentially can work in your projects. So we can do this. What we can do is we can add a constructor to our text message sender rule, and we're going to pass in two strings, one the allowed calling class and one the target class. And then we are going to update our code. So before, we had a hard-coded allowed calling class here, which was text message queue processor. And previously here, this was text message sender, the one we were limiting who we could call to. So we don't have to make much change. And then the final thing is we go back to our PHP stand config, and we pass in arguments to the rule. And now we've got something where the rule is standard and will work for everything, but the specifics that you want is just some config in your PHP stand.neon file. And it's highly conceivable that you'll want lots of similar checks to this. So all we need to do is copy and paste that, and we just change the arguments, and so on and so forth. So we can replicate this any number of times for any kind of constraints that you have. Now, I was amazed before, but hopefully you're even more amazed now. But we can do better. We can do better than this. If we're going to say text message sender can be called from text message queue processor, how do we document that to other developers? We could put something in the doc block, but the chances are people might not read that. But that's okay, because we do have this rule there to protect us. But we have to remember to document it. We have to remember to set up our config in PHP stand.neon files. And then what happens if we rename text message sender? Will our IDE be clever enough to know that it's got to go and change something in a PHP stand neon file? Maybe, maybe not. But if we make this change to our code base, then maybe the rule that was protecting us isn't going to work anymore, because maybe we forgot to update the config in the neon file. So, new language feature time. In C++, there is a concept called friend. And what you do is you annotate a class or a method and saying, by the way, my friend is this other class, and only this other class can call methods on me. So we can do this in PHP. Since PHP 8, we can have attributes. I'm going to have an attribute that you can only apply to classes, and we're going to call it friend. And what we pass into the friend is the name of the class that is our friend, okay? And then that means on our text message sender, we add the friend attribute, and we say, my friend is text message queue processor. So this, okay, maybe the first time a developer sees this, maybe they don't know what friend is, but once they know what it is, they can understand this. The code for developers and for the static analysis tool is the same. If we rename text message sender or text message queue processor in an IDE, these will also get updated. Everything stays in sync. And we don't need to mess around with any PHP stand neon file. So what we've done, we're just adding an attribute to our code to tell it about some additional information. In this case, if you like, some kind of visibility modifier. So how do we implement this? We need to update our code. We need to update the codes to find the calling class that we're in. And then so this code is as it was before. And then we're saying, does my target class have a friend attribute? And if yes, is the calling class a friend of the target class? So we've got the code we had before, and then we've just got to change these two bits. And in order to help answer those questions, we need something called a reflection provider. So we're going to update our PHP stand rule. We're going to get rid of the config that we previously put in, because we don't need that anymore. And we're going to pass in something called reflection provider. And PHP stand will just auto-wire this in. So the first thing we need to ask, does our target class have the friend attribute? So we're going to get info on the target class. Then what we're going to do is drop back to PHP's native reflection. We're going to ask it if there's an attribute called friend on it. Friend is set up so it can only be used once on a class. Some attributes you can have repeating, but by default you can only have one attribute once. So this code is just saying, have we got exactly one attribute? And if not, continue. Obviously, we're not going to worry about this. But if we do have exactly one attribute that is of type friend, we're then going to get the first argument passed into the constructor. And we're just going to check there is something passed into the constructor. There should only be exactly one argument passed into the friend constructor from the constructor method signature. And if that's wrong, some other PHP stand rule will tell us we've made a mistake. So this is just saying, have I got exactly one argument passed in? And if so, what is it? And then finally, I go, is my friend class the name of the class that I passed in? And if it is, then this is how we get the friend class. And then finally, we ask, is the calling class a friend of the target class? And if they're not, then we raise an error. So this is not a huge amount of code. This is not a huge amount of code. I'll share with you the repo where this lives, but I'm just going to put it on the screen. I don't expect you to be able to read this, but I just want to show you it's not much code, and we have created C++ style friend language feature in that amount of code, you know? If at the front and you've got good eyesight, you could almost read it. If you actually want to read the code, there's the GitHub. I'll share the links with later. So hopefully, I think this is mind-blowingly amazing. Hopefully other people do. And what you've got is you've kind of got something that is maybe just a couple of hours' work versus what would happen in the RFC process. So that means in an afternoon, you could develop a new language feature that is useful for a project you're working on. And I've got a formula for this. Custom static analysis rules plus attributes to give you whatever information you need to for the rule to work equals a new language feature. This stuff is really, really amazing, I think. Well, clearly I think it's amazing. That's why I'm up here. But I think this stuff is incredible. So incredible, I've actually written a PHP extension library where I have created some additional features, either ideas that I've had or ideas that appear in other languages. So you can find it on GitHub, PHP language extensions. The first thing we have is the friend. This implementation is slightly more complicated than the one we've just gone through. You can put the friend attribute either on the class, and that means it'll apply it to every method in the class, or you can apply just to a particular method, and also you can have multiple friends. So that's the friend. The other thing is called, another one I've made is called namespace visibility, and this sits between public and protected. And what this means is that in this case, calculate can only be called from classes in the same namespace or the sub-namespaces. So in other languages like Java, this is very close to the package visibility modifier. So if you've got a lot of code that is closely collaborating with each other, then it should only be called by other, other code within the same namespace. The namespace visibility attribute is something that might help here. So I did electronic engineering when I was at university, and one of the ideas they had there was on your integrated circuits, they would provide a couple of pins just for testing purposes. So either you could get the value of some intermediate result, or you could apply a value to it to put the chip into a certain state for testing. And sometimes in PHP, maybe we need to access data that or properties that we're only really accessing for testing purposes. So an example is maybe if you're using Doctrine and maybe you've got an entity in the database, and normally it's the database's responsibility to set the ID, but you want to do some unit test, and for whatever reason you need that ID set, then you'd have to expose a setID method. And what we can do, and there are tools to help with this that kind of, break PHP's visibility modifiers, but I'd actually advocate doing something like this. We make the method to modify the property public, but we put the test tag attribute on. And what that means is when PHP Stan is doing this analysis, it says, has this code been called from test code? If so, that's fine. Otherwise, I'm going to tell you off. And I think the benefit of this is, if you do need something for testing, then it should be part of the interface, but we can explicitly tell developers, and static analysis can protect us, to tell us that actually this is only there for test purposes. Sealed is another one. So if you have a class or an interface, this is telling you the only things that can extend or implement it. So maybe you've got a result class and you only want a success and a failure result. You don't want anything else to extend this. Injectable version. What you can do here is, if you've got hierarchies, you've got things that implement interfaces, you can say, for the purposes of dependency injection, which version of that should be used. So imagine you had a person repository. That is probably the one that should be injected into all of your service classes or whatever. So what you can do is you can mark person repository with the hash injectable version attribute. And then maybe you've got things like the Doctrine person repository, which provides an implementation. And what happens here is the tool will look at the constructor methods of every single class, and anywhere where you've got something like person repository, it will go back and say, okay, person repository is the injectable version, that is fine. But imagine if instead of person repository, I had put Doctrine person repository, then the tool would look at that and go, hang on a minute, that's not what should be injected in. You should be using person repository. And there's a couple of other ones in there. I provided an implementation of override, although that is coming to the language in a few weeks. So the definition is the definition of the attributes in the top GitHub thing. So if you go and look at that, that has just got the definitions of the attributes. And then a PHP Stan implementation of them is this second link here. So if you're using PHP Stan, then you would include this and add this to the rules that get executed. Currently, there is no implementation for SARM or for PHP Storm or anything else. But if anyone's interested, they are more than welcome to create an implementation for them. And if people like this kind of concept, then I would suggest that you do split off the attributes definitions from the tools that implement it, because that allows, if I only know PHP Stan, so I'm okay to do this, but it doesn't prevent other people from creating libraries that comply with this. And if you are interested in making a SARM or a PHP Storm implementation, what you can do is you can go to the PHP language extensions, the thing that just contains the attribute definitions, and then I have a whole series of examples, and you can go in and you can use those essentially as test cases if you like. If you go into one of there, it says this code should work, and this is where it should show the error, and so on and so forth. So it's a bit like, it's almost like a definition of how these things work. Okay, so I'd like to wrap up with some thoughts. If we think about the types of RFCs we get, I'm going to say they roughly come into these kind of properties. So you might have security RFCs. So these would be things like libsodian, for example. You might have syntactic sugar type RFCs. So we're not really adding any new functionality, we're just making it a bit easier for people. So constructor promotion would be something like that. We have performance-related ones, so maybe the JIT is an example of that. And we have new features. So recently we've got things like enum would be a newish feature in the past few versions of PHP. And then we've got things which I'm calling communicating intent. So I would argue any of the visibility modifiers like public, private, protected, things like final, things like read-only, those are the kind of what I bucket in communicating intention. They're primarily there for developers. Yeah, you might get some compiler optimizations with things like read-only and final, but their intention, what they're really there for is to tell other developers, by the way, this is read-only, or this is final, this is public, and so on and so forth. Now, of course, often there are RFCs which probably overlap one or more of these. And the kind of things that I'm talking about doing in static analysis are really only these communication intention type rules. You can't do what I'm doing to kind of speed things up, unfortunately. So the RFCs that kind of fall in this communication intention thing, so one that is coming out in PHP 8.3 is the override attribute. That's just there for other developers, really. The language doesn't care. So yeah, so things like this, public, private, protected, final, abstract, read-only, type declarations, type hints, for example, in generics, they're all there for the developers. I've added in some here, and these things are important because they're just there. They're automating checks to protect against developers making mistakes. Now, another benefit of doing this kind of thing in static analysis first is the moment any feature becomes part of the language, it is going to be there for absolute minimum a decade. We have to get it right. And sometimes, potentially, some that have been mistakes made, or maybe there would have been a better way of doing things. So the great thing is, we can try these ideas out in static analysis. So today, it's there in static analysis. We can really kick the tires. We can really see, does this work? What about this? What about that? And maybe if we have it in production, in static analysis, if you like, and it's used by many people for a year or two, by the end of it, we'll know what the problems are and what the tweaks that are made that need making. And maybe one day, and I should actually update that to PHP 9, but maybe one day it will actually be part of the language. Who knows? And actually, this has happened. The return type never started off in static analysis world, and now it is part of the language. Admittedly, probably not many people use it, but it is an example of something that's gone from static analysis world to real PHP language. And interestingly, the Friend, there was an RFC for that a few years ago, which didn't pass. And possibly because there were some objections, so now we can do things this way, and we can really iron out what any of the issues would be. So this is kind of the journey we've taken today, but I think the key takeaways I want you to remember is we can add custom static analysis rules to our projects, and they can automatically enforce whatever conventions you have. And that means you, the future you, and other developers will not make mistakes, or they're less likely to make mistakes. And also, if we like a feature from another language, potentially we can create it using static analysis. I've been Dave Liddermont. Thank you for listening. So I think I've got 4 minutes for any questions. By the way, I love talking about this, so you can come and find me and ask me questions about this. I'm here for the next couple of days. But if there is 1 or 2 questions, I can probably take them now. Okay, and if you're interested in finding anything else about it, the PHP stand documentation about developing extensions is there. This is a great book, Recipe for Decoupling, and it shows practical examples of the kind of rules you might want to add to your projects to help enforce things. I have done a custom PHP stand rules tutorial, but that unfortunately was yesterday. But maybe I'll do it again at another conference. And if you're interested to find more about the abstract syntax tree, James Tipton did a talk called Climbing the Abstract Syntax Tree, which goes, that's a whole hour-long talk based on what I've just been speaking about. Sorry, was there a question there? Okay. Yeah, so the question was, for the benefit of the recording, how can we test the custom rules? So PHP Stan, assuming you're writing the custom rules in PHP Stan, it has a whole supporting test suite for doing that. And what you do is you create a number of snippets of code, and then you say, execute this rule on these snippets of code, and this is what I'm expecting to, the errors I'm expecting to get reported. And if you go back to the PHP Stan implementation, see if I can find the URL. Oops, play that. Oh no. If you go to this one here, you can see some examples about how we write tests for it. But great question, and we absolutely should be testing these things. Cool. All right, well, thanks very much. Again, if you've got any questions, come and find me, or find me on Twitter and ask them. I love talking about this stuff, so thank you very much for your time.